Assalamu alaikum. In this lecture, we will learn what is displacement reaction in aqueous solution in solid state, and displacement reaction involving the halogens and uses of displacement reaction. First of all, what are displacement reaction? There are different type of the chemical reactions like decomposition reaction, combination reaction, combustion reaction, neutralization reaction, redox reaction, etc. And we have learned about the neutralization reaction in our previous lectures. In this lecture, we will look at the reaction type which is called as displacement reaction. So, if we define this displacement reaction in a simple mean that then it is a reaction in which an atom replaces another atom or element in a compound or in a molecule. Is it clear? So due to this displacement, this reaction is also called as substitution reaction. Displacement reaction is also called as substitution reaction. Why substitution reaction? Because one more reactive element substitute the other less reactive element in a compound and molecule. Is it clear? And this point should be clearly noted that only the metal can replace a metal and non-metal can replace a non-metal. So to understand this displacement reaction, we consider a general reaction. Let's suppose a X atom or molecule or element combine with a molecular compound like YZ, and it gives the new compound XZ and Y. So in this reaction, it is clear that the X replaces the Y in another compound, and this reaction exists only if a X is more reactive than Y. Then it can replace the other element, or then it is the only case the X replaces the Y. So the less reactive element like the Y is remain the uncombined and form a new or a pure element or separate element. Is it clear? So it means that the displacement reaction is all about the reactivity of the atom or elements, and we know that in a periodic table, if you see in a periodic table, the more reactive elements are more electropositive or electronegative elements, and we will discuss these two classes in a displacement reaction. So the first one is the reaction or displacement reaction involving the metals, which are the more electropositive elements, and we know that the alkali and alkaline earth metals are more reactive and the more electropositive as compared to the transition metals or heavy metals. Is it clear? So first of all, displacement reaction of metals in aqueous solution. Is it clear? So for this we take an equation or an example to understand this reaction. Let's suppose we have equation like magnesium metal combined with copper sulfate solution, and it gives us copper and magnesium sulfate. As I'm taking as a solution, so magnesium sulfate will be in an aqueous, and copper sulfate will be in an aqueous solution, and magnesium is a metal, so it will be in solid state. Similarly, in a product side, copper is a metal, so it will be in a solid state, and this will be the aqueous solution. Is it clear? So in this equation, in this reaction, we can see that the magnesium metal replace the copper from the copper sulfate and form the magnesium sulfate as a compound. Why it replaces? Because magnesium is a more electropositive or more reactive metal as compared to the copper. So when the magnesium is added in a copper sulfate solution, it will substitute the copper and form the magnesium sulfate. And we will observe the reaction by changing the color of the solution. At the first, before starting the reaction, the solution color is a blue due to the copper sulfate, but after the reaction, the solution color pale. And if we add the more amount of the magnesium in a solution, then solution become colorless due to the formation of the magnesium sulfate. Is it clear? So if we see the ionic equation, for ionic equation, ionic equation, definitely the compound in a solution will dissociate into their ions, and so magnesium is a metal, so it will remain as a solid state, and copper sulfate in a solution, it will dissociate into its ion, that is copper ion in a aqueous solution and sulfate ion in aqueous solution, and give us copper metal is, it will in a solid state, and magnesium ion in aqueous solution and sulfate ion in aqueous solution. So cancel out the common ion from on the both side, then sulfate ion will cancel out with the sulfate ion, and we get the final equation as, so our final equation will be magnesium solid and copper ion in a aqueous gives us copper solid and magnesium ion in a aqueous. Is it clear? So it is clear that this is a redox reaction. Why it is a redox reaction? Because the electron transfer, because there is a oxidation state change in the reaction. At the first, the oxidation state of the copper was 0, and then it is the +2, and uh, the oxidation state of the copper before the reaction was +2, and after the reaction it is 0. So it means electron transfer from magnesium to the copper, and hence the magnesium atoms are oxidized and copper atom are reduced. So both reaction are take place here, so it is the redox reaction. It will be redox reaction. Is it clear? Okay, take another example, that is the number 2 is the metal displacement reaction in solid state. Solid state means all the reactant and product are at the solid state. They are not present in a liquid state or in a gaseous or in a solution form. Is it clear? So to understand this reaction, let's suppose we have a reaction aluminium combined with ferric oxide and give us iron and aluminium oxide. So for the balancing equations are balance, as the aluminium is a metal, so it is a solid state. Ferric oxide is present in a solid state. Similarly, iron is in a solid state and aluminium oxide is in a solid state. Is it clear? So reactant and product are in a solid state. So to start the chemical reaction, we have to heat up the reaction or heat up the system so that the reaction can be started. So for this purpose, the thermite method is used. So in this mixture, in a mixture of the iron, ferric oxide and aluminium mixture, with a magnesium fuse is lit, and this reaction is occur. Is it clear? So this is the same reaction by which the railway industry rails are joined together instead of the welding. Because it is a highly exothermic reaction, so iron that is formed will be in a molten state. It will is present in a molten state due to the exothermic reaction. So that molten iron flow into the gap between the rails, and iron then cools and join the rails together. Is it clear? And for the ionic equation, For ionic equation, definitely after the heating up the system, the solid will convert into their melting state. So aluminium, it is a metal, so it will melt as aluminium metal, and iron oxide in a liquid state. Similarly, oxygen in a liquid state, iron again in a liquid state, aluminium in a liquid, and oxygen in liquid. So again cancel out the same ion and we get the final equation as aluminium and iron gives us iron and aluminium ion. Is it clear? So again it is clear from the equation that it is a redox reaction because oxidation states are changing here. Aluminium convert to aluminium ion Al plus 3 from 0, and iron plus 3 convert into the iron 0 oxidation state. So again electron transfer from aluminium to iron, so it is a redox reaction. Is it clear? And now number 3, the displacement reaction in halogens. Now what are the halogens? In a periodic table, the group 7a group is called as the halogens, and they are called as the halogens because they form the simple salt when they react with the metals. Is it clear? So if you see the different element in a halogen group, it starts from the fluorine, then chlorine, then bromine, then iodine, and then astatine. So these are the 5 members of the halogen groups, and these elements are arranged on the basis of their reactivity. It means fluorine is a more reactive than chlorine, chlorine is a more reactive than bromine, bromine is more reactive than iodine, and iodine is more reactive than astatine. So when they react with each other, the more reactive element will replace the less reactive element from the compound. Let's suppose we have a reaction like chlorine gas is passed through compound potassium bromide, and we will get as bromine and potassium chloride. Again they are in an aqueous solution, so we write the aqueous here. So it is clear that as the chlorine is more reactive than the bromine, so bromine is replaced by the chlorine molecule. Is it clear? And again if we want to write the ionic equation, the ionic equation will be as they are present in a aqueous solution, and chlorine is a molecule, so chlorine remains the unchanged in aqueous solution, and the potassium ion and bromine ion in a solution is give us bromine in an aqueous solution, and similarly chloride ion and potassium ion in aqueous solution. And again cancel out the similar ion, we get the final equation chlorine in an aqueous solution plus bromine ion in an aqueous solution give us bromine in an aqueous and chloride in aqueous. And again it is clear that it is a redox reaction because electron transfer from chlorine to bromine, and again the chlorine is reduced and bromine is oxidized due to the loss of electron. Is it clear? So if we see the uses of the displacement reaction, so displacement reaction can be used to investigate the reactivity of the metals, because in this reaction the highly reactive element replace the less reactive element, so we can check the reactivity of the metals or elements, or we can extract the metal from the metal oxides or ores on the basis of the reactivity of the element. Is it clear? So this is all about the reaction lecture. Thank you.